Good morning, friends. Today we are going to discuss about the welded joints. So basically, we already studied about the welding types of welding. What are the different welding operations? Generally, welding is done to join a similar or dissimilar metals. So during joining of any metals by a welding joint, how much amount of strength that we can get from that welded joint that we have to study here. So the what is the welding process? So welding is a process of joining the metals with the application of heat with or without application of pressure. It means you can add a pressure or without application of pressure you can get a welded joint. So basically what are the different advantages of welding process? The first very important advantage that is highest joint efficiency. Lighter in weight, easier to make alteration. It means if you want to disassemble these two metals which have joined by a welded joint, you can it is a very easy method to make alteration. Any joint or structure can be welded. It is low cost and good appearance. Okay, but the main disadvantage is the thermostats that will be induced due to uneven heating and cooling effect. Second one, the welding is a process in which very high amount of heat is generated, so there is a very high heat affected zone, and the propagation of failure or fatigue creep cannot be prevented. So it is somehow the introduction of welded joints that is an advantage as well as a disadvantage. Now look at the welded joint. It is the simplest type of welded joint. So the basically welded joints are the two types. So one is a butt joint, another that is fillet joint. Whenever these two metals are joined by some type of welding, this is known as a simple butt joint. Okay, where the L is a length of weld, height H is a height of weld, and P is a thickness of blade. So suppose if we are applying a force P at each end to separate these plates, the how much amount of strength that can be obtained by this welded joint, we can calculate by the maximum tensile stress sigma T, that is equal to force over the area. So what is the force? Force is a force P. What is the area? So here we are considering the only the weld portion area of this area. So there is a thickness T and length L. So whatever the area that between the thickness T and length L, this area that we are considering for tensile stress consideration. So that is a basically tensile stress equation or load carrying capacity of welded joint of butt joint, that will be P is equal to sigma T into TL. Look at the some extrapolated figure where there is a thickness is divided into the three parts. Generally this type of finishing to the joint has been done to avoid some disadvantages of welded joint, and we can get more strength. Okay, so these are the portion that is known as a reinforcement. This reinforcement can be removed by the grinding machine, and here extra metal is removed by the grinding that will generate compressive stress at here, that will improve always for surface finish. So what is my sigma t at here? Sigma t is generally considered where our welded area is there. So I can say P upon T1 plus T2 into L. Here we are not considering T3 because there is no welded portion. Okay, so here our area will be only T1 plus T2 into L. Okay, that is a simple type of butt joint. So whenever they ask the what is the stress concentration, what is the load bearing capacity of butt joint, so you can calculate by only this simple equation. Now come to the second joint, that is known as a fillet joint. When these two plates are parallel to each other and we are joining these two plates with the help of the welding, this welding is known as a fillet joint. It is a top view of plate, and if you look at the side view, this fillet zone that will appear like this. This S is known as a size of weld zone. So whenever the fillet joint that will be there will be a S. This S term denoted by the size of weld. Now this is a designation of the fillet weld. Okay. This A, C, and B. Okay. This A to C is also size of weld. This C to B is also the size of weld. Okay. So it is a one type of butter T. Now side view. S is the size of weld or flat thickness. So whenever we are applying force P to the weld, fillet weld, we know that there is a shear stress because the surface contact area, and we are applying a force parallel to the weld. So there will be a stress generated, that will be shear stress, and this material will fail due to shear stress only. Okay, so we have to know about the shear stress. What is the maximum shear stress? We know that whenever we are applying the force by a Mohr circle, our shear stress will always generated at a 45 degree to the normal stress axis. Okay, so look at to the some type of analogy of this fillet weld. This is the fillet weld. Okay, but if I join A to B, so my triangle ACB, where AC is the size of weld, CB is size of weld, my material will fail always from the least thickness. So my least thickness, if I draw a line perpendicular on the AB from C, that is CD line, so CD is my least thickness. So if I calculate the area at CD into L, that will be my least area, and material will fail at this point. But at how much angle this CD line exists, that we have to calculate. Okay, so what we are going, that is CD is a throat thickness. We can say it is a throat because in our body our throat has a least thickness. Okay, so we can here say that CD is our throat thickness. And let's zoom out this figure. ACB, ACB, okay, ACD, ACD. It is our size of weld. It is our throat thickness. Here is the angle of 45. Okay, because it is a similar triangle S and S, so it will be a 90, 45, 45. It is a theta. So the summation of all triangle angle, that will be 180. So I can say this angle is 180 minus 45 minus theta. So from that I can say my shear stress will be force P upon area, that is T dash throat thickness into length of fillet weld. Okay, now look at the thing. My shear stress tau is equal to P upon T dash into L. So I want to find out this T dash. To find out this T dash, I am using a sine rule or Lami's theorem. What is my T dash? That is T dash upon sine 45 is equal to, we know the S size of it, S upon sine 180 minus 45 minus theta. Okay, so T dash upon sine 45 is equal to S upon 180 minus theta. Sine pi minus theta is equal to sine theta. So I can say sine 45 plus theta. So my T dash will be S sine 45 upon sine 45 plus theta. If I expand this sine 45 plus theta in sine alpha plus beta is equal to sine alpha cos beta, cos alpha sine beta. So I can say here sine 45 cos theta plus cos 45 sine theta. So again, if I put a value of sine and cos, I will get sine 45 is equal to 1 by root 2, and cos 45 is also 1 by root 2. So by putting the value of the sine 45, we will get the T dash is equal to root 2 as sine 45 on cos theta plus sine theta. Okay, so sine 45 is again 1 upon root 2. Root 2 will be cancelled out. You will get T dash is equal to S upon sine theta plus cos theta. So your throat thickness will depends on this angle theta. Okay, which angle? That will be this angle. This throat thickness depends on this angle theta. So for maximum, okay, we can say shear stress tau is equal to P upon, if you put a throat thickness, SL sin theta plus cos theta. But we have to find out maximum shear stress. Now the shear stress is dependent on only on theta. So for maximum and minimum condition, what we are doing, we are taking the differentiation, put it equal to 0, and finally we are getting the same relations, and then we can find out the maximum or minimum. So same thing we are going to here. Okay, so what is a d tau by d theta? Because the tau is a function of only theta, so d by d theta is equal to sin theta upon sin theta plus cos theta, because p upon sl is not a function of theta, so we are only derivating the sin theta plus cos theta, and you will get theta is equal to 45, and if you put theta is equal to 45, you will get tau max is equal to root 2 p upon sl. So here we can get P is equal to 0.707 SL SSY upon FS, where SSY is equal to shear strength of material, FO is equal to factor of safety. This equation is a very important equation for exam point of view as well as numerical point of view. Now we know that tau is equal to P upon SL for normal, but here we are using the 0.707 SL SSY upon FOS. So what is the throat thickness? So throat thickness is equal to, we have equation T is equal to S upon sin theta plus cos theta, we are obtain theta is equal to 45, so you will get throat thickness is equal to 0.707 of s. It means 70% of your size of weld, that is throat thickness. So you can say throat thickness is the least thickness and throat area is the least area. So finally tau max is equal to load upon throat area. Okay, so tau max is equal to root 2 pi upon SL. We have already known throat thickness is the thickness of maximum shear stress plane. So where is the maximum shear stress? That thickness, that is your throat thickness. Now it is a some type of 0.707 as. So this is a somehow the design of the welded joint. Okay, now during this welded joint, this equation P is equal to 0.707 SL SSY upon FOS is the most important equation. Clear? Okay, so these are the somehow about the welded joint. Again I am repeating the same thing in a very fast way. So what are the welded joint? Advantage is higher joint efficiency, lighter in waste, easier to make location, low cost, good appearance. Disadvantage, thermal acid stress will be induced due to uneven heating and cooling, heat affected zone. We have two types of welded joint: butt joint, fillet joint. For butt joint, plates are parallel and that will be joined. Okay, here what are the tensile stress? Sigma T is equal to P upon TL, where T is the thickness of plate. Okay, for fillet weld, we know the size of weld, but we have to find out the least thickness from where the maximum shear stress is generated. So for that, we have consider one analysis. In analysis, we have to find out this theta for these 3 days, and we come to the equation that 3 days is equal to s upon sin theta plus cos theta, and we have put the equation into shear stress equation. So for maximum shear stress, we have gone the differentiation for this. This will be, that will be P is equal to 0.7001 SLSSY upon FY. So there is a 1 5 mark question for exam point of view from starting from this fillet weld. What is a fillet weld? Okay, derive the equation for load carrying capacity of fillet weld with the size of weld is equal to x. So you have to come up to the here. Okay, and finally, what is a 1 mark new questions? What is a throat thickness? Where is the maximum shear stress? What is the equation of tau max? These are the some um, relations of the welded joint. Okay, so here we are concluding our riveted joint as well as the welded joint. From next lecture I'm going to start design for the screws. Okay, the assignment of the welded joint that I'll be circulate within today. Okay, and deadline will, that will be given in the assignments. Okay, thank you.